Hey guys, this is Jeffrey once again. I'm going to do this video primarily on different classes and also visibility modifiers for data members in those classes. I'm also planning on going over functions, which are one of the most important things you'll put inside the classes you write. So, as a basic definition, in Java, a class is a collection of data and functions that is typically used to achieve a specific function. So if you're writing a game, for example, you might have a class that represents an enemy, and you can make multiple instantiations of this class to put multiple enemies in the game. In this example here, I'm going to go through a much simpler example, just to try and highlight the key aspects of what a class is and how you use it. So to start here, this is the main class, and it's the main class because it has the main method in it. There are a few things that right off the bat you should notice in the main method. First of all, it's declared public. The reason it's declared public is when the Java application starts, this method has to be visible to be called. The public visibility modifier says that any other class is able to see this method and therefore call it. Main in reality is only called by the Java runtime, or through the Java runtime, and it's called once to begin the application. Static simply means that all instances of this class main are going to share the same method here. A better way to say static would be shared. If you change a static variable or have a static function, all classes will have that exact same value or function. So in this case, main is declared as static, and void. Void is the return type. In this case, there's no purpose in main returning anything because we're not actually calling main from our own code. So to say that it returns nothing, you'll say void. A common mistake that people make is to type null right there. That is bad, and it's not what you're supposed to do. Null is used to denote an object that has no memory allocated to it. Void is a return type that says this method returns nothing. Just something to highlight. So you'll notice here, up here, what I have, these are called instance variables. These follow a lot of the same conventions I was talking about before with public would mean that this integer could be accessed from any class. Protected says it can only be accessed from subclasses, which we'll get to later when we talk about inheritance. We can mostly forget about that for now. And there's private, which means only this class itself can see this variable. Or rather, I should say, only a specific object of this class can see that variable. If something is declared final, it means its value once assigned can never change. If something is declared static, as I said before, it's shared among all objects. So if you were to have two objects of type main, and you changed the value of ID in one of them, the value of ID in the other would also change. So this is a very useful tool, but beware that having static variables can lead to errors if you have two classes referencing the same variable. So a quick warning about static variables and methods is that a static method can only access static variables, and it can only access static methods. So you'll at least from outside of it. Inside of it, you can declare variables, but in terms of the global instance variables, it can only deal with things with a static modifier. So as you see here, I'm calling this method I wrote print up to with the value ID. When I run this code, the first thing you'll see printed out in the console is 0, 1, 2, 3, 4. It's printing up to, not including the value of ID. I had to use ID here because it's the only instance variable I have that's static. And since this is a static method, that's all that will work here. Notice here that this method print up to also is static. If I take that out, it will throw an error right here and say you have to make that static in order for main to be able to call it. So methods, just to go down here real quick, are just like it's just a set of code statements that are executed when it's called. You call it simply by putting the name of it and in parentheses any parameters. And so in this case, a call to print up to with the number just printed all the non-negative integers up to that number. It's fairly simple. So that's about it in terms of what you can do in main. A lot of what you're going to be doing in Java, in fact what Java is built for, is in other classes. So here I've defined something called a class. This class has some instance variables. One's public, two are private. It has two constructors, some methods, and a toString method, which is a very special method I'll talk about in a minute. The first thing to notice here, these two constructors. Constructors are what determine how an object created, how a class is instantiated as an object. You can create as many objects from a class as you would like, as I'm doing right here. They all have the same data fields, but the value of those can change. This allows the object to have different state and therefore function differently from other objects of the same type, although the functions it can perform will always be the same. So in this case, I have what is called an overloaded constructor. I have one constructor in which you pass nothing, and number is automatically initialized to 3. 3 is considered a default value in this case. I have one constructor in which you pass a number. In this case, the instance variable number is given the value of what is passed. So going back here, I'm instantiating 3 different objects. One does not pass parameters, 2 of them do. So when I run this, it is going to call a method in that class, print up to number, which is basically the same as this print up to method right here, but it's acting on the data in each of those classes. So what you'll see is in this first case, it printed up to, not including of course the number 3. That's because number is automatically initialized to 3. In the other one, it goes up to the number just before 5, and then in this one the number just before 7. So you can see here the function of that object is determined by its state, by the values to which its instance variables are set. The next thing that's really important to highlight here is the idea of public variables. I mentioned before they can be modified outside the class, and you'll see right here object.badIdea equals 9 is setting this integer, this public integer called badIdea, to a different value from outside of this class. The reason this is a bad idea is because if you're working with a team or with a group of developers, you want to make sure that any code you write can only be modified in certain ways. You don't want your classes and objects to be able to be easily changed by someone who doesn't understand the inner workings very well. In your own code, it's best practice to have things be private and use certain methods called getters and setters, methods whose only function is to return the value of a certain parameter, or rather instance variable, or to set that value, and to not make it public, simply because that's the way things are expected in the real world. Technically, you could write a fully functioning program with only public variables. It's not advised, and it's much better practice to make them private. So I'd say just go ahead and do that, and then as you program, you'll understand why that's a good idea. It's kind of hard to see in the beginning, but you'll see right here in the beginning, this print badIdea comes out with a value of 7. That's what is initialized to an A class. But after you change it, object.badIdea is now 9, and it prints out that value of 9. You have just changed the object of a class, from outside that class. So that can be kind of dangerous, as I mentioned before. The next big thing I wanted to highlight here, is this static right here, the static variable. Static variables are shared among all objects of a class. So right here I'm instantiating 3 objects of class A class. And notice that in my constructor, in both constructors, I'm incrementing count. That means that every time I instantiate an object, count is going to increase by 1. So as you see here in this output, each object knows that 3 objects of its type have been instantiated. So that really just goes to show that the static variable allows you to share state for a class, not for a specific object. Instance variables, as opposed to static variables, save state for a particular object. To head back to a class, well, first in here, you might be a little bit confused, and it would make sense that I'm printing out this object because this object isn't of type string. The reason I can do that is because I have overridden the method toString. ToString is a method that a lot of people expect to see in objects that basically says, when you print this, what do you want displayed? And all you do is return a string value here. So that's why I think that a total of 3 objects of my type has been instantiated was printed out when I say print object 1 and object 2. It's actually just calling this toString method. So this is a very good method to know. It allows you to control basically how the object is represented when it's printed. That's about it. So that's really it for what we're going to talk about with classes, methods, and instance variables today. I would just like to mention return types can be anything you want, but if you specify a return type, you have to return a value of that type. For instance, when I say public static int, print up to int number, I would have to do return, and in this case, since there's not really much it could return, that's why I made it void to begin with, I'll just say return 10. If I don't have that statement there, the function won't be allowed to run. It'll throw an error. Notice, though, that a call to print up to number, or print up to, like this, does not need to store the returned value. I could say int x equals print up to 5, but I don't have to. So just because you're returning something doesn't mean you have to do something with the returned value. So for now, that's really all it is. It'll be good. I would highly suggest you guys experiment with this, different return types, different parameters. You can have as many parameters as you want, and learning to use these different visibility modifiers and constants as well as static variables. But that it's nothing too hard, and once you get the key concepts, it's very simple. So I'll leave you with that.